And with that, I'm going to announce the first speaker, Dr. David Lynch. He's at the Children's Hospital of Philadelphia, affectionately known in the region as CHOP. And he specializes in Friedreich's ataxia and other childhood diseases. Please welcome Dr. David Lynch.
So thank you very much for inviting me to speak here, as I've done several times in the past. Today's talk is a little different, but I'll refine it back to my usual topic because that's the way I tend to be. It's a very diverse group here, as I think you all know, with some things in common, but many things that are different. So being asked to speak about childhood ataxias and recessive ataxias, and trying to find a talk which unites some of the things that they have in common as well as amplifies a few differences can be a little difficult. I'll also mention right now that if people have individual questions that they want to ask me, I'll be around for a little bit after the talk, and then I'm back all afternoon for the Birds of a Feather session, so you can just find me then. So I'm talking about Friedreich ataxia and other childhood ataxias. I have to show the usual disclaimer, which is required that be careful about anything that you see here should be talked about with your individual physician to be sure that it's actually perfectly correct for you. The other disclosures is that I do have a lot of funding sources, including grants from those 6 pharmaceutical foundations and or 5 pharmaceutical companies, as well as the Friedreich Ataxia Research Alliance at the end. So pediatric ataxia. Ataxia, when most people think about it as an adulthood phenomenon, is also relatively common in children as well. In children, in contrast to adults, it usually constitutes a recessive disease, if it is genetic, in which each parent is a carrier and has no symptomatology. Dominant ataxias do present in childhood, usually with a very severe phenotype, particularly those who carry so-called CAG repeat disorders in which there's a substantial amount of anticipation. But if you go into a pediatric neurology department, most of the ataxia you see that is of a genetic nature is recessive. The most common of these is Friedreich ataxia, which I think everyone knows I see more frequently than anything else. We at CHOP follow about 350 people with FA. It is an ataxia including both sensory aspects in which people cannot localize where their bodies are in space, as well as primary issues in the cerebellum itself with difficulties of coordination. The other aspects to Friedreich ataxia which are important and actually are the life-threatening aspects of it are heart disease, where people have an unusual type of heart disease where their hearts become thick, leading to difficulty of handling large fluid loads, and then eventually in some individuals that thick muscle changes to fibrous tissue and becomes unable to pump. So that issues arise with life expectancy in 20s and 30s in some, but not all individuals. The other big issue outside the nervous system in Friedreich ataxia is scoliosis. About 70% of people with Friedreich ataxia have scoliosis, and about 40% will actually undergo surgical correction of this, usually in your teenage years. So that's the time when scoliosis becomes most problematic and orthopedic surgery may be necessary. In addition, about 20% of people with FA get diabetes. It can be both early onset or it can be much later onset. So it's really both a type 1 and type 2 like phenomenon. FA is the most common disease we see. Slightly less common is a disorder known as ataxia telangiectasia, which is another one that most neurologists and pediatric neurologists should know about. It's a little bit different in that most of the difficulty arises not from the loss of the sensory neurons early, but difficulty with the cerebellum itself, the area concerned with balance, getting substantially smaller. You also get other nervous system issues, including movement disorders. And by movement disorder, what a neurologist means is difficulty moving without true weakness, so developing unusual postures, tremor, rigidity. These things can come on quite early in ataxia telangiectasia. The other key issue in ataxia telangiectasia is all those things that occur outside the nervous system, which I would actually argue are more problematic than most of those in FA. That includes pulmonary difficulties, as well as sensitivity to radiation and sensitivity to oncologic neoplastic, cancer-causing processes, so that the entire management of people with ataxia telangiectasia has to include limitation of exposure to things which can potentially cause cancer because people are much more sensitive. That's one of the biggest long-term issues. In addition, cognitive issues are relatively prominent in people with AT. After Friedreich ataxia and ataxia telangiectasia, which I always call AT, if you go to your local pediatric neurologist, you will usually see a reaction from them because they have not realized that they have actually met people with these other disorders because they're all described in the time since these individuals went through residency. There are large numbers of them, and it is impossible to cover them all in a 2-hour talk. So I'm not going to try and cover them all or even mention them all, but try and mention a couple of them as well as the things they may have in common. There are two which are probably closely related to ataxia telangiectasia, not only at the clinical level in that they have mainly issues with the cerebellum itself, but also at the scientific level in that there's evidence for difficulties in repairing DNA. These are called ataxia with oculomotor apraxia, type 1, and ataxia with oculomotor apraxia, type 2. It's brilliant. You know, they sent us to school to learn how to name things like that. Probably some federal tax dollars went into that. So think about that when you think about your next donation. So these are characterized, many people have difficulty moving their eyes, but not everyone does. So the names in some way are misnomers. It just describes how we first found them. Another syndrome which can occur in children more than in adults is a group of disorders called ataxia with coenzyme Q deficiency. What is this? Children, sometimes adults, who present with slowly progressive ataxia, whose feature is that if you look at some place in their body, blood, muscle, sometimes other tissues, they don't make enough of the vitamin called coenzyme Q, the stuff you can buy at the grocery store. That's important because that coenzyme Q deficiency is important in at least some cause of the pathophysiology, and some individuals with this disorder will recover to normal with administration of coenzyme Q. This is not common, but because of that response, it's important that a person know that they don't have one of these syndromes. There's an easy way to figure it out. Have your doctor get you some coenzyme Q or go to the grocery store on your own and take it a little bit. It is that responsive in its most responsive elements. And then one more, which is a very specific disorder called ataxia with vitamin E deficiency, a disorder where you look almost identical to Friedreich ataxia, but it comes not from the gene from Friedreich ataxia, but from a different gene which keeps you from absorbing vitamin E, or really absorbing vitamin E very well. It is, again, early on, 100% treatable, with large quantities of vitamin E, about 10 times what is commonly given to individuals for other purposes. So that is an entirely treatable one. So those two disorders of ataxia with coenzyme Q deficiency and ataxia with vitamin E deficiency, every child who has ataxia, you should be sure that they do not have them. That's the single most important thing I say, even as I'm going to talk about a lot of other stuff, because those are entirely treatable on, April 6, 2018. Got to check up on the date. So there are numerous other ones that have been identified genetically. Some of them can be identified commercially, some of them can't. We can't go through them all, but what do they have in common? Well, in all of these, including Friedreich ataxia and ataxia telangiectasia, the key element to maintaining one's abilities and even improving, stabilizing long-term is being active. The more you do, the more you do. Another brilliant statement we learned in medical school. The way to keep that doing is rehabilitation and physical therapy. You will find people, and you know this better than most doctors do, how important it is to simply stay moving, because the more you train yourself to move and stay on balance, the better you stay on balance. If you're being denied physical therapy, please ask your doctor to fight with your insurance company. The other aspects is that we talk about these as ataxia, but most of the pediatric ataxias are not pure. They have other features involved, which sometimes can be responsive to therapeutic medications. AOA1 and Friedreich ataxia both have a large component of neuropathic pain that is readily treatable by the generic gabapentin or other related agents. Relatively well tolerated except for occasional sleepiness, but they can be very, very important in managing the disorder. In addition, in most of these disorders, while we talk about their balance difficulty, there is an underlying loss of the neurons which control strength and motor tone, so-called corticospinal tract or upper motor neurons. When people lose those, the spasms they get and the stiffness can be responsive to muscle relaxants such as baclofen, which is not habit-forming and is a relatively safe medicine. The other thing is, as you go to talk about pediatric ataxias and look at clinical care, be sure that the non-neurological manifestations are being managed. It might require a neurologist to step outside of their comfort zone. Wouldn't want to do that. Or maybe it requires being sure that your family physicians and primary care physicians are well integrated in the care. So the person with AT is having their pulmonary manifestations taken care of. The person with FA is having their cardiac manifestations taken care of. These are things whose importance cannot be overstated. After that, the different pediatric ataxias start diverging. And they all share a genetic basis, and the individual therapies that come from research, you must realize if they are directed at that genetic basis, they will be relatively selective for the disease in question. That is, therapies designed specifically to control Friedreich ataxia will have limited, if any, applicability to ataxia telangiectasia and vice versa. The selectivity allows, to a certain extent, the safety, but also allows the frustration that progress in one disorder does not always mean progress in another. How do we try and move forward? Well, the way we do this, as you heard Harry talk about yesterday and was introduced before, is systematic research. And that is the way we find new things. So I will mention a little bit more detail about Friedreich ataxia, because it is Dave Lynch actually talking here. Remember, the Friedreich ataxia is about 1 in every 50,000 people, a number that you don't really need to know, but I have to have memorized. So they're about, when you mentioned that people are not alone, many people with FA don't realize there are about 4,000 to 5,000 people in the United States, which doesn't sound like a lot until you go to collaborative groups that can put 40 or 50 of these people in a room together, just as this conference today puts 40 or 50 people of different ataxias together. It is FA, like AT and other ones, it's thought about as a neurologic disease, but in fact involves multiple systems. Not everyone with FA is the same. For example, if you, the people who have the worst genetic abnormalities have... see if I get, oops, wrong thing. Go forward one. With the worst genetic abnormalities present in childhood, and they have the most difficult course. Usually the onset is between 5 and 15, but it can be later in the teens, and even the latest person I see with presentation was age 65. So it can really drag out through life and when people show up. The later onset individuals do have slower progression, and I will say they never get heart disease, so their life expectancy is unaffected. If you go through the individual items in FA, what you might have talked about, ataxia, difficulty with balance, difficulty with speech, which is a particular mixture of upper motor neuron and cerebellar speech, loss of reflexes, loss of sensation, and I'll note the loss of reflexes occurs before you ever go to see a neurologist. And to a certain extent, muscle weakness, really not because the muscle degenerates, but because the muscle isn't functioning well. Cognition is relatively spared, although more recently we're identifying things as you get larger cohorts and more systematically examine them. There's a very selective loss of cells. It is largely in the sensory pathways very early, probably, in my opinion, before we meet people, but if Massimo Pandolfo was here, he would be disagreeing with me. Fortunately, Massimo's not here today. Later parts of the cerebellum itself actually change. Most people have heart disease as well as curvature of the spine. About up to one-third of people have diabetes or some component of it. I like to call it type 1.5. What do I mean? Early disease is type 1 diabetes, insulin dependent from the beginning, and you don't make enough insulin. Late diabetes, the sort that those individuals who are 58 and who have a family history and might have too much cholesterol and have high blood pressure, and I wouldn't know anyone like that, tend to get type 2 diabetes, which is not usually insulin requiring early, but can be managed by diet and exercise. People with FA are halfway in the middle. That is, they don't make enough insulin, but they also are not sensitive to insulin, so that they will get it either early or they can get it late sometime, like other people in the room who might be at the front of this room right now. So it's really type 1.5, depending on who they are. In addition, they get muscle issues which are there and really affect their ability to stand and walk, but we don't see them on exam because they're not severe enough, but I do believe they affect people's lives, are important. One thing I will mention is the difficulty in vision in FA. The textbooks say that about 5% of people with FA get vision loss. Well, one thing we have done over the past 2 decades as we have followed people longer and longer is we see more and more people with vision loss. I think it's not because it's increasing in true frequency, it's because we're following people and looking more. This becomes a major issue long term, which we're actually in discussions with several companies about specific therapy for the vision loss of FA. It says 5% in the textbooks. I would rate it closer to 50% of the early onset individuals. And this is not unimportant because it does reach levels of 2,200, which is quite problematic. People with FA can present as early as age 2, as late as age 75 in the literature. Most people are using wheelchairs by their late 20s, if not earlier. It's about 16 years after diagnosis. People die from only one thing if they die early, and that's heart disease. One thing we discovered when we started looking at a large group of individuals is that people with FA are systematically small. This is a curve where what we've done is look at the body mass index percentiles across a large group of FA and compared them to the population. And the left-hand side is people who are really, really thin. Not necessarily enough to be worked up by their pediatrician, but right at that border. And about 20 or 30% of the people with FA fall in the first 10 percentile rank. So people are really, really thin with FA. This is a part of the disease. If you do fall below the 5th percentile, your pediatrician will want to look at things. They don't have to look farther than Friedreich ataxia as a cause. How do we know it's part of the disease? Because we can induce it in mice when we knock out the frataxin gene. What is the genetic basis of Friedreich ataxia? As many of you know, it's from a triplet repeat, which interferes with production of the protein we call frataxin, another brilliantly named event. The GAA actually gets the length of it determines the relative phenotype. And some people, about 4%, have one abnormal GA repeat as well as a single base change in the other gene they have. And remember, you have to have 2 abnormal genes to get FA. That single base change knocks out the protein, usually keeps it from the frataxin protein from being made. You can look at that GA repeat, and we look at the shorter one. And this graph here correlates on the y-axis, the age at onset, the time we meet people with FA, with the number of GA repeats in the smaller allele. As you look at this graph, you can see it looks like a line. So the longer your GA repeats, the earlier it gets to be. Now, since my daughter has a test on hyperbolas today in her math class, I would think everyone would recognize that it's really a hyperbola. And so that's actually part of the mathematical construct. So those of you who have teenage kids who are going through pre-calculus right now, you should realize that it will be used later in life. We know that we've done pretty good research on FA because this curve is from Alessandra Durer. I don't know if she's still here, but she was here earlier in the week. This is from 1997. We could generate exactly the same curve now, which means we sort of get Friedreich ataxia. And what Friedreich ataxia represents, and this is from Sanjay Bidichandani, as you look at the Western blots here, is simply you don't make enough of the protein we call frataxin. No more, no less. And those individuals who have not 2 GA repeat lengths, but 1 GA repeat length abnormality and a point mutation so they don't make any protein at all off of that, they look exactly the same as people with typical FA. What that tells us is really it's the protein and nothing else which is the issue. Carriers have 50% of normal levels, and they are entirely normal human beings from a medical perspective. So I'll let people who have FA talk about their parents who are obligate carriers any way they choose. So this is simply frataxin deficiency. Compared to the other ataxias, this is a relatively simple disease biochemically. What does frataxin do? It helps you make energy. This is a diagram that Rob Wilson borrowed from a biochemistry book a long time ago. Frataxin allows you to put iron in the enzymes which make energy in your body. As a result, FA is simply an energy disease of selected cells. So it's relatively a simple disease. You know, these GA repeat links turn the gene off so you don't make enough frataxin. That leads to difficulties making energy in your mitochondria, and specifically the enzymes that use iron and sulfur. That happens in certain cells, and that leads to disease. So we've got 4 steps, and this is what we said in 1997, and thus this should be a really easy thing to treat/cure, correct? Well, it's not quite so simple. One, because you can always learn more about the pathophysiology. But the other thing is studying rare disease, which is essentially what this room is about, is not so easy. When you look at the typical diabetes study or the typical hypertension study, it will be a study of 1,000 people. Even Parkinson's disease, you will have high hundreds numbers of individuals. That would be the entire population of many of the diseases which we all talk about. So there are not that many people to participate. They're spread across the United States. And even there, not everyone looks identical. And from a viewpoint, if people aren't identical, how do you mix or match them together? And that's actually a substantial portion of what clinical research is. So how fast have things moved in FA in terms not of success, but in terms of trial? We found the original GA repeat link mutation in 1996. We sort of knew it was in mitochondrial in 1997. So if we look back at the FRDA pipeline and all the drugs in development from several years ago, you can produce this slide. This is a 2016 slide which Jennifer Farmer's given me, and there we are. And what you see as each one of those different lines going from the left to the right is a different drug or a different class of drugs at different stages of development. All the way to the right means it's sold at your drugstore. So many of them have gotten a large way there, but none of them have gotten all the way there. This emphasizes one thing, is that things can move fast when people work together, but also that you have to do a lot of things and get things all the way across from the left side, which is testing in cells, then to testing in animals, then to safety in humans, then to chip shots in humans if thinks it's the Masters weekend, and then finally to actually putting it in the whole or winning the Masters. We'll compare it to that. That takes a lot of steps, and only by systematically going through and everyone working together can you get there. So the simple things you need are these. And you might recognize the guy who's smiling in such a very weird way right now. He's around the audience, I'm told. As well as another one of my patients who's a substantial amount younger than Kyle. You have to find a way to measure the disease. And measuring the disease as we do research-wise is not the same as simply going to your doctor. Measuring what I do in the office when I see someone with ataxia is my goal is to take care of them. That's not the same as necessarily doing a research test. And do not take research results as dogma for clinical care. A lot of people want to know the detailed research results. It's more important whether you feel better and whether you do better in your life than what my numbers say. The next thing is we have to have blood tests and other simple ways to triage mechanisms, drugs as they come forward. That's where a lot of work is right now. We also have to know what the destiny of people is as they move forward, what the natural history data is. That allows us to tell us what the roadmap should be, and if we know the detailed roadmap, we'll know a lot better whether we've done better than expected or worse than expected in a shorter period of time. That's why if you're in FA, you participate in one of the various natural history studies, and if you're in autosomal dominant or other ataxias, you work with the NAF to participate in one of their natural history studies. I would note the next thing is you need funding. One of the most effective things I would mention is the natural history studies, places where people can go to participate in simple research protocols which are largely observation. How have things changed? How have blood tests changed? This is incredibly important. Every one of those drug companies who you saw in the FRDA pipeline is with us because of the natural history background. This is easier for FA because people are more alike, and it is harder for autosomal dominant and other ataxias, both based on scarcity and based on the complicated phenotype. But these natural history studies are appearing, particularly as funded through NAF and the autosomal dominant ataxias and their rare disease and their UO1 grant from the government to move forward. If you have the opportunity, I encourage you to go to these sites. Not every place does them. There are 10 sites for FA in the country. I forget the exact number for autosomal dominant since I'm not directly involved. But if you can, please go. They usually have money to cover your travel. The other thing to keep in mind is as you see them, it may not officially be clinical care. I don't know any researcher who will decline the correct answer to a question if you ask it to them. So you'll get free medical advice if you're looking for it. This map here shows we have a collaborative group in Europe and in the United States in FA. The stars are where people are. Different places follow a different number of individuals, and it's not that hard to get to them, and I strongly encourage it. The other thing I want to go back to the pipeline is as I look at this color-coded guide here, each color is a different type of molecule, a different approach to treating disease. Simple story, since we're just after Easter, don't put all your eggs in one basket, because you never know what the future holds in terms of risk. There may be new side effects that none of us have imagined, which appear. And if you put all your eggs in one basket, this pipeline would stop. This is one of the things which have been done well in FA, even if none has gotten to the finish line. The other thing is for research studies, we have to find a way to meet you all. So I can come out here and talk, and I don't want to call this an advertisement, but there's another way. I believe NAF, and I know FARA run what we call registries. You go in there, you deposit, in the case of the FARA registry, a minimal amount of information: your name, your email address, and your age. Then when any study appears, be it a clinical trial or something else that you could participate in, you get an email and say, call the site if you really want to do it. It allows studies to recruit very fast, and in rare diseases, that is the biggest issue. If you can't find the people, you don't get there. FARA has a registry. NAF also has a registry for dominant ataxias. And I see my time's running out, so I'll speak faster. I didn't think that was possible. The other thing to realize is when you go, blood samples, cheek swab samples, skin biopsy samples are very important. This says what we hold in our freezer across town. We hold DNA. What that's about to be used for is a large gene modifier study where someone's going to look for other genes across 1,000 people that are involved in FA and new targets. Each drug company that we work with wants to see blood tests that they could design for their drug. They can know that if we send them samples derived from patients originally, and then they can study them. We do the same thing with cheek swabs. This is used to pilot the data which they will use in clinical trials. In FA, there are 3 open clinical trials. The most important to say, there's 2 which are running in multiple adult centers, the RT408 and TK831, as well as the epicatechin, which is enrolling children at Mayo. So people will ask me, well, how's this, is that the drug which will work? And I will say the most important thing, the study is going well. I am well blinded. I have no idea whether people are getting better or not. And that's the way you do a fair experiment, and that's what the goal is. So remember, the goal through studies is that we all get to the finish line by getting the right answer. And I think I'm going to skip that one since I've shown multiple times. If anyone wants to know all the drugs, I'll talk about them, the birds of feather, later. In addition, the things for conclusions, pediatric ataxias are usually recessive. Remember physical therapy and general care. Do not forget coenzyme Q deficiency and vitamin E deficiency. And further research is the way to moving forward across anything. If you want to find me, that's my name, that's my email address. I don't go anywhere except to my office and like here and home. That's about it. I don't travel. So if you have questions, email me anytime. Thank you for your attention. I tried to speak slow.